Dear students, we are going to discuss about the problems on equilibrium constant. So in the previous lecture, we are discussed about the how to express the equilibrium constant in terms of concentration and in terms of pressure also. Yes, now we are going to discuss. Yes, listen. My name is Lakshmi Narayana. We are discussing the equilibrium reactions, equilibrium chapter. So now look at once. We'll discuss about this problem. So what is the problem here? At constant temperature, 80% of AB dissociates into A2 and B2. Then the equilibrium constant for 2AB gives rise to A2 and B2 is. So look at the question carefully. So for such type of reactions, so they are told that equilibrium constant, it is dissociate 80%. So the 80% dissociates nothing but the degree of dissociation you have to find out. So degree of dissociation alpha, it is equals to 80 divided by 100, then you can get 0.8. So it is the alpha. Then for such type of reactions, which type of reactions are? So 2AB gives rise to so A2 plus B2. A2 plus B2. Then look at carefully, such type of reactions nothing but so 2HI gives rise to H2 plus I2. Then 2NO gives rise to N2 plus O2. For such type of reactions, we can use one of the formula directly, that is equilibrium constant K equals to alpha square divided by 4 into 1 minus alpha whole square, like this. So here alpha square, so what is the alpha? 0.8 whole square. So divided by 4 into 1 minus 0.8 whole square. 0.8 whole square. So now 0.8 into 0.8 we can get it is 0.64 divided by 4 into 1 minus 0.8 that we call it is 0.2 whole square. Then here you can get 0.64 divided by 4 into 0.2 whole square, you can get it is 0.16. Then finally you can get the 4. So answer is 4. So that's why this is the option. So listen my dear students. For 2AB gives rise to A2 and B2. For such type of reactions, we can use this formula directly. Which is the formula? Sir, equilibrium constant K equals to alpha square divided by 4 into 1 minus alpha whole square. You can use this formula. Note it, then we'll discuss it. Yes, look at the next problem. HI was heated in a steel tube at 440 degrees Celsius till the equilibrium was reached. HI was found to be 22% decomposed. The equilibrium constant for the dissociation of HI is. They are asking a question like this. Then even though options are given like this, then option 1 0.282, then option 2 0.0796796, then option 3 0.0199, then fourth option is given, that is 1.99, like this. Then before problem, the previous problem we are discussing that. So such type of reactions, which type of reactions? HI dissociate, for example 2HI, when it is dissociate into H2 plus I2. So for such type of reactions, I told that equation formula, that is K equals to alpha square divided by 4 into 1 minus alpha whole square. So then what is the alpha thus? So alpha it is equals to degree of dissociation. I told degree of dissociation. So how much percentage is dissociation? 22% is dissociated. So 22% divided by 100, then you can get what? 0.22. So then here, if you substitute this, so K equals to, so 0.22 percentage whole square divided by, so 4 into 1 minus 0.22 whole square if you do. Then here, if you solve this, then here you can get it is 0.0199. So this is the answer for this. Then, so Kc value for 2AB2 A2 plus B2, such type of reactions, you can do the direct formula for this. Then note it, then we will discuss the next problem. Yes, look at the next question. That is 2 moles of PCl5 is heated in a 1 liter vessel. If PCl5 dissociates into the extent of 80%, the equilibrium constant for the dissociation of PCl5. The previous question and this question, the type of reaction is different. So now look at the question. So PCl5, when it is dissociate into PCl3 plus Cl2, it can be dissociate like this. But even though they are mentioned here also, 80% is dissociated. So nothing but degree of dissociation. So that is degree of dissociation is equals to 80 divided by 100, then you can get 0.8. So 0.8 for 1 mole. But actually here they are mentioned 2 moles of PCl5. So it is 2 moles at initial stage when time t equals to 0. So in the 2 moles, 80% is dissociated. So in the 2 moles, 80% is dissociated means you have to take it is 2 into 0.8, nothing but. So 1.6 moles of that particular compound is dissociated. So you have to take here 2 minus 1.6, it is dissociated. So then 0.4 moles you can get here. So here 1.6 it is dissociated means the products also will form 1.6 and here also 1.6 will be formed. So now we have to find out the equilibrium constant for this particular reaction. So Kc equilibrium constant is equals to PCl3 concentration into Cl2 concentration divided by PCl5 concentration. Then PCl3 concentration at equilibrium, what is there that we have to take equilibrium. So 1.6 into 1.6. So look at 1.6 into 1.6. So divided by, so what is there here? 0.4. So 1.6 into 1.6, 2.56 divided by 0.4. So 2.56 divided by 0.4, in case if you solve this, then you can get here 6.4. 6.4 is the answer. So for this 6.4. So such type of reactions you have to do the reaction. You have to do the problems like this. So first you have to know the reaction. So how much is dissociated? For 1 mole 0.8, no problem. No doubt at all. Then here 2 moles you have to take it is 1.6. You have to multiply with 3 moles. 3 multiply with how much degree? Like that. Yes, I hope it is understand. Just note it. We'll discuss next problem. Yes. Now look at the next problems. That is, the initial concentration of A and B are same. For the A plus 2B gives rise to 3C. And when equilibrium concentration of B and C is same, then Kc is what? So your first initial concentration of A and B are same for the particular reaction. So what reaction is given here? So A plus 2B gives rise to 3C, they are given like this. So if you observe, A and B are same concentrations at initial stage they told. So that is why just assume when time t equals to 0, we are taking A also 1 mole and B also 1 mole. Both are same moles. Then if you come to the equilibrium concentrations, how much percentage is dissociated, they are not given. So in the previous problems, if you observe that 0.8 percentage is given and something is given, like that they told. So now we have to take it is just x moles of dissociated. So at equilibrium, that is x moles is formed. So here when x moles or x percentage is discussed here, dissociated. So how much stoichiometric coefficient number is there, for that you have to multiply. So nothing but 3x. Then here 1 minus, sorry, x moles. Here how much is dissociated? X moles. So that is why we have to take x. But how many stoichiometric coefficient is there, that you have to multiply this. Then even here 1 minus x, like that you have to take it. Understand? Then these are the equilibrium concentrations. Now they told that, so B and C concentrations are same. Then what? So B and C both can equal it first. So 1 minus 2x plus equals to 3x. So 2x send that side. So 1 equals to, so 2x if it is go that side 5x. Then x equals to, so 1 by 5 you can get. X equals to 1 by 5 you can get. So nothing but, so here x value you can get 0.2. Look at 0.2. So here 0.2 value, substitute in all these concentrations. For example, on this if you take, so 1 minus, sorry, A concentration, take it is A concentration, 1 minus x, nothing but 1 minus 0.2, then you can get what? So 0.8, you can get right. Then B concentration, what is there? B concentration here actually, what is there in this? 1 minus 2x. So here 1 minus, so 2x, nothing but, so 2 into 0.2, nothing but 0.4, 0.4 equals to, so then 1 minus 0.4, 0.6 you can get. Then C concentration, so that is equals to 3 into x, 3 into x, x is to, x how much? X how much? 0.2. So 3 into 0.2, 0.6 you can get. 0.6. All the concentrations we have got at equilibrium position. These are the original concentrations for the equilibrium position. Now equilibrium constant. So how to write it is, so C power 3 divided by, say, A into B power 2. Then C power 3, what is there? So C power 3, C concentration, how much is there? 0.6 power 3 have to take. Then A power, what is A? 0.8, 0.8. Then B concentration, what is there? So B concentration is 0.6, so 0.6, so whole square, like this. So why whole square you have to take? Because stoichiometric coefficient is 2. Then here just we can say that 0.6 whole square, then cube, take it 0.6 divided by the 0.8. So 0.6 divided by 0.8, you can get 0.75 the answer. So 0.75 is the answer. So such type of problem you have to do like this. Understand all of you? I hope it is understand. Just note it. Yes. Next problem look at. 1.2 moles of SO3 allowed to dissociate in 2 liter vessel. The reaction is 2SO3 gives rise to 2SO2 plus O2. And the concentration of oxygen at equilibrium is 0.1 mole per liter. Note it. the total number of moles at equilibrium will be. So the previous problems they are asking equilibrium constant. Now they are asking equilibrium, just at equilibrium position, total number of moles are how much. So then one more thing here, they have mentioned that 2 liters vessel. These are all the things we have to remember first. So what equation is given, that note it first. So 2SO3 is sliced to, then 2SO2 plus O2. 2SO2 plus O2. Okay, right. So now at initial stage, so what is there, sir? 1.2 moles is there. So here at equilibrium position, oxygen 0.1 mole per liter. Per liter there. But actually how many liters are there? 2 liters are there. So per liter 0.1, then 2 liters 0.2. So that is why oxygen equilibrium we are taking it is 0.2 liters. So remember that per liter it is equals to 0.1. Per 2 liters it is equals to 0.2. That's 0.2 we are taking, which is oxygen concentration. Then here in case if you take, so here also 0.2 we have to take it as 0.4 because 2 moles. Then here, so 0. Here even though here 1.2 in case if you take. So how much it is dissociated per mole? So 0.1 is dissociated. That means oxygen will be formed. For 2 liters, 0.2. Here 2 stoichiometric coefficient 2 is there, so that is why minus 2 into 0.2, nothing but 0.4. So here at equilibrium, it is time t equals to 0 initial stage. At equilibrium what happens? At equilibrium 1.2 minus 0.4, 0.8 you can get. Then here 0.4 you can get. Then here 0.2 you can get. So total number of moles they are asking. Total number of moles equals to 0.8 plus 0.4 plus 0.2. Then you can get finally 1.4. This is the answer. 1.4. Just note it. 1.4. Understand all of you? Yes, I hope understand. Just note it. Yes, look at the next question. So here 3 moles of acetylene or ethyne converted into benzene. This reaction is performed in a 1 liter vessel. Equilibrium is established when 0.5 moles of benzene is present at certain temperature. If the equilibrium constant is 4 liter square mole inverse to the total number of moles of substance present at equilibrium is. Again the same total number of moles they are asking. So previous question also total number of moles, even this question also total number of moles. But somewhat different question it is. Look at carefully. So 3 moles of C2H2 acetylene when it is converted into benzene C6H6. So here one of the things they are mentioned when 0.5 moles of benzene is present at certain temperature, equilibrium is established. So at equilibrium they are mentioned that is 0.5 moles. Then so here one more thing, equilibrium constant also is given, that is 4. So here one thing you have to remember it, at initial stage what is the concentration of this? 3 moles. They are mentioned in the question itself, 3 moles. Then when it is dissociate into 0.5 moles, then even here also you have to remove 0.5 moles. Then here 3 coefficient is there, so 3 into 0.5 moles. Then 3 minus 1.5. 3 minus 1.5. So because 3 into 0.5, 1.5. So here finally you can get it is 1.5. These are the equilibrium, original equilibrium concentrations. Now if you substitute in the Kc, so Kc equals to what? That means equilibrium constant equals to what? Equilibrium concentration for this reaction, how to write? C6H6 then divided by, So C2H2 power cube we have to take. Then K is C value 4, equilibrium constant value. So here 0.5 equilibrium constant. Then divided by C2H2 taken cube. Then send this side, 4 send that side. C2H2 whole cube equals to 0.5 divided by 4. Then you can get 0.125. 0.125. Then in case if you take C2H2, then is equals to, that side if you send it is 0.5. So whole cube, we can write 0.5 whole cube. 0.5 whole cube. Then finally, sir, C2H2 concentration, you can get it is 0.5. So at equilibrium, so both concentrations are, actual concentration is not this. So both concentrations are same like that too. So if for 3 moles it is 1.5, but actually 1 mole 0.5. Then they are asking total number of moles. Total number of moles equals to, benzene already mentioned that is 0.5. Benzene mentioned 0.5. So 0.5. Even acetylene also concentration we got it is 0.5. So 0.5 plus 0.5, 1 is the total number of moles. Understand? Yes, I hope it is understand. Then note it. We will discuss next question. Yes, look at the next question. 0.1 mole of ethyl alcohol and 0.1 mole of acetic acid are mixed at equilibrium. 0.666 moles of ester is formed. The value of equilibrium constant is. So which are ethyl alcohol, that is what, C2H5OH. So when reacts with acetic acid, that is what, CH3COOH. When reacts, ester is formed, that is what, CH3COOC2H5. Plus even water also is formed like this. So it is a liquid, then when it is also liquid, it is also liquid. The concentrations you have to take. So whatever it may be. So now we are going to discuss about the equilibrium constant. So before going to the equilibrium constant, they are mentioned at an initial stage. So here 0.1 mole. So not 0.1 mole actually here. So 1 mole. 1 mole of. So even though 1 mole of, 1 mole of. So 1 mole of ethyl alcohol. Then 1 mole of acetic acid is present at time t equals to 0. At equilibrium they are mentioned, that is 0.666 moles of ester is formed. So it is, we have to take it as 0.666 moles. So once it is removed as 0.66 moles, it is dissociated as 0.66 moles at equilibrium position. From the 1 mole, if it is removed 0.66, you can get it as 0.333 moles. Then here and here also 0.333 moles. Even water also will be formed, that is 0.666 moles. So Kc equals to what, you can write it is actually, sir, CH3 COOC2H5 concentration, sir, into H2O concentration, so divided by C2H5OH into CH3COOH equals to, so both concentrations you have to take it, 0.666 into 0.666 divided by 0.333 into 0.333, then you can get the answer finally, that is 4. 4 is the answer. Understand? So you have to do like this for such type of problems. Yes, note it. Then we will discuss next. Yes, look at next question. It is somewhat different. The previous they are given moles, but now they are given it is grams. So 28 grams of nitrogen and 6 grams of hydrogen were heated in a closed vessel. At equilibrium, 25.5 grams of ammonia is present. So look at, observe it carefully. First these two are at initial stage. Then this is at equilibrium stage, which is 25.5 grams of ammonia present. Approximately what is the value of Kc? There are some questions. So what is the equation here? So N2 plus 3H2 gives rise to 2NH3. This is the equation. There. So now N2 is given 28 grams. Then H2 is given 6 grams at initial stage. For this you have to find out the number of moles. So number of moles equals to given weight 28, molecular weight 28, then you can get 1 mole. Even though here number of moles, if you want to find out, given weight is 6 grams, then molecular weight 2 grams, so then you can get here 3 moles. Okay. So at time t equals to 0, it is 1 mole is there, it is 3 mole is there. Now, sir, here ammonia, they are given it is molecular molecular grams, that is 25.5 grams. Then now number of moles of ammonia equals to 25.5 divided by 70 molecular weight, then you can get 1.5. So it is at equilibrium position, ammonia got 1.5. Okay. Then before going to that, so just a small discussion I will give to you. So that is, so before going to that, we don't know exact what is the number of moles of converted into that. So that is why. So here we are taking it is 2x moles we can take. So 2 stoichiometric coefficients of 2x. Then here 3 minus how many moles? 3x. Then 1 minus x, like this. Sir, how much it is dissociated? X moles. So stoichiometric 2 is there, so 2 into x. Stoichiometric 3 is there, 3 into x. Then x like this. Understand all of it? Yes, not yet. Now, here, when at equilibrium position, then here 2x, it is equals to 1.5 because they are mentioned this many grams like this. So 2x equals to 1.5, then x equals to 1.5 divided by 2 equals to 0.75. Then in case x value, when it is substitute here and here, then you can get actual equilibrium concentrations. So that is why we are going to find out that. So first nitrogen concentration N2, that is how much is given? 1 minus x. So 1 minus x value 0.75, nothing but you can get it is 0.25. So H2 value, so H2 concentration, actual concentration 3 minus 3x is given. So equals to 3 minus 3x, nothing but 2.25. So then you can get here 0.75. Then ammonia concentration, that is, so ammonia concentration is equals to then 2x, nothing but 1.51, right? So Kc, if you substitute all the values, so what is the Kc here? So NH3 taken power 2, so N2, then H2 power cube, like this. So NH3, what is there? 1.5 whole square. Then N2, what is there? N2 concentration 0.25. Then next H2, what is there? 0.75 whole power cube, like this. So if you substitute all these values, then finally you can get answer, that is 21.33. So this is the answer, 21.33 is the answer. Understand? I hope it is understand. Then note it. Next question we will do.